Have you ever talked to your phone and just marveled at how it actually understands you? Or, how your email inbox is magically free of all that junk mail? Well, today we're pulling back the curtain on the technology that makes all of that happen. We're going to talk about how we actually teach machines to read.
I mean, really think about it. How does your inbox know what's spam? And how does a shopping site sift through literally thousands of product reviews and tell you, yep, 85% of people liked this? There isn't a massive team of people reading every single one. The secret is the same for both.
And that secret is a little something called text classification. At its heart, it's about training a machine to be a super fast, super accurate librarian. It's teaching it how to read, sort, and label mountains of text in the blink of an eye. Okay, so let's get into it. Before we can really compare all the different models out there, we need to understand the basic recipe. How do you actually get a machine to read in the first place? It all boils down to these 6 key steps. First, you gotta have data, lots and lots of labeled data. Then you have to clean up that text. That's called preprocessing. Next up is the really crucial part, feature extraction. This is where we turn human words into numbers a computer can actually understand. And only then can you train a model to spot patterns, evaluate how well it's doing, and finally deploy it to work on brand new text. This whole process, this recipe, is a cornerstone of modern AI. And this isn't just some abstract theory, right? This process is everywhere. It's behind sentiment analysis, which tells companies if your review is happy or angry. It's used for topic classification to sort news articles into sports, politics, or tech. And yeah, it's the unsung hero of spam detection. It can even figure out a customer's goal in a support ticket to get them to the right person faster. All right, let's start with the simplest type of models. I want you to think of these like a little pocket dictionary. They don't learn or anything. They just follow a set of rules someone already wrote down for them. So our first model is called VADER, and it was built for a very specific purpose, to understand the messy, chaotic language of social media, with all the slang, emojis, and people shouting in all caps. The thing that makes VADER so great is its speed. It literally just checks words against its internal dictionary, where every word already has a score for how positive or negative it is. It's even smart enough to understand that not good is a bad thing. But here's the catch. If a word isn't in its little dictionary, VADER has no clue what to do. It's totally lost. Okay, next up in our rule-based category is TextBlob. So if VADER is that specialized dictionary for social media, TextBlob is more like your general-purpose, beginner-friendly version. It's a fantastic starting point.
TextBlob's whole deal is simplicity. Seriously, it's so easy to use. It gives you 2 main scores, polarity, which is just a rating from negative to positive, and subjectivity, which is its best guess on whether a sentence is a fact or just someone's opinion. It's handy, for sure, but it's not as sharp as VADER and can get tripped up by tricky grammar. It's perfect for learning or for quick and dirty analysis, but maybe not for your company's main product.
Okay, time to level up. We're moving on from those fixed rule books to models that can actually learn from data. Picture a student who's been given thousands of flashcards and is starting to see the patterns. And that right there is the fundamental difference. The rule-based models we just talked about, they're static. They can't change. But machine learning models are dynamic. You train them on these huge data sets of examples, and they learn to recognize patterns all on their own, so they can make predictions on text they've never seen before. So, our first machine learning model is an absolute classic, naive Bayes. It's a statistical approach that works by calculating probabilities. It looks at the words in a sentence and asks, what are the odds this text belongs in this category? Naive Bayes is super fast and gives you this nice probability score. Like, I'm 80% confident this email is spam. But it has one huge, glaring blind spot. It treats every sentence like a simple bag of words. It completely ignores grammar and word order. So, to naive Bayes, the sentences man bites dog and dog bites man are exactly the same. That's why it's called naive. It's making a pretty simplistic assumption, but hey, that's also what makes it so fast. All right, now it's time for the main event. We are entering the world of deep learning. These are the models that don't just see words. They understand context, they get nuance, they see the relationships between words. These are the true literary experts of the AI world. So let me introduce you to BERT and its even more powerful sibling, RoBERTa. These are what we call transformer models, and this architecture was a complete game changer for the field of natural language processing. Their superpower is something called bidirectional context. Think about it. The meaning of a word in a sentence depends on the words that come before it, but also the words that come after it. By looking at the whole sentence at once, from both directions, these models can finally understand really complex stuff like sarcasm and subtle nuance. Now, the only trade-off for this incredible power is that they are absolute computational beasts. They need a ton of processing power to run.
So that raises a pretty important question, right? If BERT and RoBERTa are so amazing, why aren't we just using them for everything? Well, it turns out that state-of-the-art accuracy comes with a pretty hefty price tag.
And to really get why, we need to talk about hardware for a sec. A CPU, which is the brain in most computers, is like a Formula One race car. It has a few incredibly powerful cores that are designed to do one thing at a time really, really fast. A GPU, on the other hand, is more like a massive fleet of delivery trucks. It has thousands of smaller cores. It can't do any single task as fast as the race car, but it can do thousands of things all at once. And here's why that difference is just so critical. Training a model like BERT means doing millions and millions of calculations that can all be done at the same time. It's a perfect job for a GPU's parallel power. A training job that could take weeks on a CPU can be done in just a few hours on a GPU. So for this kind of deep learning, a GPU isn't just a nice-to-have, it's basically a requirement. Okay, it's time for the final showdown. We're going to feed this one tricky sentence to all 5 of our models. It's got some mixed sentiment, right? It starts off super positive with dramatically good, but then ends with a little critique. Let's see how they handle it. And here we go. The results are in. And when you look at that, all 5 models correctly classified the sentence as positive overall. But look closer at those confidence scores. VADER and TextBlob did fine, but BERT is almost 99% sure it's positive. Why? Because it understands the context. It gets that could have been gorgeous is just a minor note, and it doesn't cancel out that powerfully positive phrase, dramatically good. It actually understands the nuance. So what's the big takeaway from all of this? It's not that one model is always the best one. It's about choosing the right tool for the job. If you need lightning-fast analysis of tweets, VADER is your champion. If you've got a ton of data and just need a solid starting point, naive Bayes is great. But if accuracy is everything, and you've got the hardware to back it up, then you spring for RoBERTa. It's always a trade-off between accuracy, speed, and cost. And that leaves us with a pretty wild question to think about. For basically all of human history, understanding the deep, subtle context of language was something only we could do. But as AI gets better and better at it, you have to wonder, what's the next frontier? What's the next thing we're so sure only a human can do? Something to chew on. Thanks for watching.